Good day. Today we shall be talking about addition, subtraction, and of course multiplication of surds. In this topic, we'll be talking about the definition of surd. We'll define surd. We'll discuss like surds. We'll discuss how to simplify surds. Then the addition, of course, the multiplication of surds. Alright, so let's quickly start with the definition of surds. A number which can be expressed as a quotient m over n of two integers, that is, when n is not equal to 0, is called a rational number. So when we say a number is rational, it means the number can be expressed as a ratio. The word rational is from the basic word ratio. Do you understand? So we can have a ratio of two numbers. For instance, if you have 3 over 4, this is a rational number. Can you see that? So number, even if you have 2 as a whole number, 2 is also a rational number. You have 2 can be expressed as 2 over 1. So any real number which is not rational is called irrational number. Can you see that? So any number that cannot be expressed as a ratio of two integers is not irrational. Any number that cannot be expressed as a ratio of two integers is not a rational number. So they are called irrational number. Now, these numbers which are in form of roots are called surds. So when we have irrational numbers expressed in form of roots, then we call them surds. So, or we call them surdic numbers. For instance, we have root 2, root 3, we have root 5, or even pi. These are irrational numbers. But root 2, root 3, and root 5 are surds. Do you understand? Okay. Now, so this study of surds is actually study of numbers with square roots and making sure that those numbers are irrational. Do you understand? Alright, so now root m is taken to mean the positive square root of m, and n root 3 is called a radical. For instance, if you have root 5, for instance, that is a surd. Can you see that? It's not possible for us to find the square root of 5 to get a whole number. No. But if you have root 4, you can have 2. So root 4 should not be called surd. Do you see that? Can you see that? Why? Because that's a whole number square root. But root 5, can you see root 7, root 2, root 3, etc. Root 13, root those there are so much. Root 19, etc. They are surds because they are square root of numbers that don't have a whole number. They cannot get a whole number square root. Okay, now let's talk about like surds. What are like surds? When two surds have the same number in the square root, then these surds are called like surds. Can you see that? For instance, if you have 2 root 3, 4 root 3, 5 root 3, 6 root 3, 7 root 3, this is 2 root 3. Can you see? So these numbers having 3 alone in their square root, they are called like surds. You can also have 3 root 2 and 6 root 2. You can have 10 root 2, 4 root 2, 6 root 2, 8 root 2. They are like surds because of the root 2 that is common to them. You can also have 2 root 5, 3 root 5, 8 root 5, 9 root 5. As long as we have the same number in the square root, they are termed like surds. Okay, so we'll be talking about simplifying of surds. Now, how do you simplify surds? Now, to understand this part of the topic, we need to understand the two basic rules of surd. That is the multiplication rule and division rule. We have just two of them for this, and these are the laws. Note, the illustration demonstrates that the fact root mn, if you have root m times n, and so that gives us root m times root n. And if you have root m over n, and so that gives us root of m over root of n. Can you see that? But if you have root m plus n, if you have root m plus n like this, that will not give us root m plus root n. No, that's a pitfall. Likewise, if you have root m minus n, that will not give us root m minus root n. No. So it means if you have root and you have m minus n inside the root, you can't do anything. Just all you can do is to say m minus n if possible, and find the root. You cannot split it as root of m minus root of n. You can only do the splitting when we have multiplication and of course division. Do you understand? Okay, so let's try if it's true. Now, by putting m equals 16 and n equals 9, Find which of the following pairs of expressions are equal. Look at number 1. I said it is true that root mn equals root m times root n. Let's confirm it. Place m for 16 and slot 9. For n in number 1. So root mn, that's root of 16 times 9. Let's say if to give us the same thing as root 16 times root 9. So after number 1 here, 16 times 9 will give us 144, and root 144 gives us 12. So let's try if that's possible in terms of splitting. Root 16 times root 9. Root 16 will give us 4. Root 9 3. That 4 times 3 gives us 12. Okay, can you see that that's correct? I told you that number 2 law is wrong. That root m plus n is never equal to root m plus root n. You don't split it. Let's see to confirm that illustration. If your m is of course 16 and n is 9, slot it here. So if you have root 16 plus 9, add the 2, that gives us what? 25. So what is root 25? That gives us 5. So let's now do the splitting. What is root 16? Root 16 will give us 4. What is root 9? 3. What is 4 plus 3? 7. Can you see that they are not equal and they can never be equal? Therefore, don't use that law that root 16 plus root m plus root n equals to root n plus root n. No. Can you see that? So root m plus n is never equal to root m plus root n, but root m plus n equals to root m plus n. You cannot do anything. You can't split it. You cannot split addition and subtraction. You can only split multiplication and division. Okay, so you can try the rest by yourself and see that some are correct and why some are wrong. Okay, so now that we understand the two rules, that root mn equals root m times root n for surds, and root m over n gives us root m or all over root n in surd. Alright, so to simplify surd, where the square root sign as a product of the factor, to simplify surd where the square root sign is a product of the factor, one of which should be a perfect square. Then simplify the surd taking the square root of the perfect square. Now what am I saying here? I mean that, for instance, if you are asked to simplify a surd or to express a single surd in its basic form. Now this are called single surd. When you have only one number inside the surd, inside the square root, you call it single surd. But this is a basic surd because we have two numbers. We have a number before the square root and a number inside the square root. Basic surd. This is single surd and this is single surd. Alright, so let's simplify. Now A says root 45. As you can see, 45 is a number that has a perfect square in it, which is 9. 45 can be expressed as 9 times 5. Can you see that? So root 45 is the same thing as saying root 9 times 5. Don't forget that our law says if you have root m times n, that gives us root m, split it times root n. You only split for what? Multiplication and what? Division. Alright, so if you do that splitting, you have root 9 to be what? 3, and root 5 cannot be more simplified. So you leave your answer as, sorry, that should not be that should give us root 5, not root 3 there. Sorry. Alright, so you correct it in the video. Now for root 150, 150 can be expressed as 25 times 6. Now 25 is a number that has a whole number square root, so that can be simplified further as what? Root 25, which is 5, and root 6 can't be simplified further, so you have your answer as 5 root 6. Now how do you do this? Look at 45. Look at 45 very well. Express 45 as a product of two numbers whereby one will be a perfect square and the other one will not be a perfect square. So the one that is a perfect square, you find the square root and you get a whole number, and that one will be outside the square root. While the one that you have it impossible to find the square root, which is a non-perfect square number, will remain in the square root. Do you understand? Alright, so let's look at 3 root 15. The real question is 3 root 75. Sorry for that. It should be 3 root 75. Look at it there. Now for C, we have 3 root 75. What do? 75 is a what? A product of 25 and what? 3. Good. And of course, I know you would have said 3 in your mind. So we have 3 root 25 times 3. Now look at 25 can be expressed as what? 5 times 5. So you can have a whole number square root. Therefore, you can say this is 3 times, split your square root. Now, so we have root 25 and root 3. Now, if you find the square root of 25, that gives us 5. So you say 3 times 5, since they are both whole numbers now, that gives us 15. So you have 15 root 3. But you cannot find the square root of 3, so you leave it in that way. So you have 15 root 3. Do you understand? But it's simple. When you see the number in the square root, express that number as a product of a perfect square and a non-perfect square. Then find the square root of the perfect square that leaves the square root, then leave the non-perfect square in the square root, and you are done. Alright, so example 2 says express as a single surd. Or to express this as a single surd. Now, I told you these two are examples of basic surds. How do we express numbers as single surds? Don't forget, when we have a single surd, how do we express 45 as a basic surd? We split it into two numbers, one perfect square and one non-perfect square. We find the square root of the one perfect square. But in this case, we do the opposite. We have a number already expressed in basic form. So what do you do? Because we found the square root of the one outside, don't forget. So you have to do the reverse. We square it. So 5 root 6 is the same thing as saying square root of, you put it as the general square root. Now 5, you take the square of 5, you square the 5. So when you square the 5, it falls under the square root. Then 6 is already in the square root, leave it like that. So you have 5 squared, that gives us what? 25. Then 25 times 6 give us what? 150. And you are done. You have root 150 as your answer. It's not clear. Now let's take number 2, which is 2 root 11. The same thing, bring the 2 inside the square root and square it. So we have 2 square times 11. So we have 4 times 11, that's what? 44. Then you have a single surd saying of root 144. I believe that is very clear. Okay, so today your assignment is to do the evaluation. We have 1 ABC and 2 express A in basic surds, and also express D and E as single surds. I believe the class is clear. Thank you, and you have a nice time.